Hello everyone, this is Group 2 screencast for Step 5. To refresh, our group is comparing indirect versus direct therapy for the treatment of oral pharyngeal dysphagia in 4 elderly stroke patients. Our first outcome is improvement in functional oral intake. This was assessed in 2 ways, using the Functional Oral Intake Scale and the Mann Assessment of Swallowing Ability, or MASA. The Functional Oral Intake Scale was given prior to the start of either treatment and again at the completion of the 6 weeks. MASA was taken at baseline, at the conclusion of treatment 1, after removal of this treatment, and at the end of treatment 2. These measures were obtained by an experienced SLP who specialized in swallowing disorders. During the pre-treatment assessment of the functional oral intake, each participant was rated a 5, indicating the need to alter multiple consistencies of different materials for oral intake. Following this, the SLP administered a clinical exam using the MASA. These measures helped to establish each patient's pre-treatment swallowing severity and was used as a reference point to evaluate future behavioral changes during subsequent sessions. Also, MASA data was cross-referenced with data from the SWAL Quality of Life to determine if a correlation between these measures was found. Our second outcome was physiologic changes on instrumental swallowing studies. This was obtained using a standard video fluoroscopic swallowing evaluation and an 8-point PAS rating system. Data was taken before treatment, following treatment 1, during the second return to baseline phase, and after the completion of treatment 2. These imaging studies were used to confirm the presence of oropharyngeal dysphagia. All studies started with a lateral view in which aspiration could most efficiently be detected and ended with an anterior-posterior view to access swallowing symmetry. Each participant participated in a number of swallow trials at each phase. A mixture of barium and food or liquid was used with a variety of consistencies and amounts. Materials were presented in 5 and 10 milliliter volumes in a variety of thicknesses, for example, thin liquid, thick liquid, pudding, and cracker. As the participants swallowed, a fluoroscope was moved near the throat to watch the swallow and projected onto a monitor where the images were captured for digital review. Each participant was evaluated during the procedure for residue post-swallow and evidence of airway compromise. 2 independent reviewers confirmed the reliability of these evaluations, and each trial was scored 3 times. A PAS rating was given to each participant for each swallow trial as well. This is an 8-point scale that is used to describe the airway compromise in each swallowing performance. A score of 1 indicates no material entered the airway. 2 to 3 indicates that material did enter the airway but stayed above the vocal folds. 4 to 5 indicates the material contacted the vocal folds, and scores of 6 to 8 indicate that the material passed through the vocal folds and describes if an attempt to clear the material was made and whether or not it was successful. Here, each swallow was scored independently. The video fluoroscopic evaluation was used to determine the nature and the extent of the swallowing disorder and analyze the effectiveness of the postures, maneuvers, and bolus modification implemented. The PAS allowed for the assessment of multiple score reliability. Our third outcome concerned the increased use of the genioglossus muscle using SEMG data. Here, electromyographic activities and video fluorographic images were obtained, and the relationship between EMG recordings and video fluoroscopic images demonstrating bolus transit times during different head postures was examined. This data was collected at pre-treatment baseline and consecutively each day during direct therapy. EMG recordings were taken during laryngeal movement of each swallow. A sensor was placed between the cricoid and thyroid cartilages to detect muscle movements for each swallow. Posture recordings were made in 2 different positions, chin up and chin tuck. EMG activity allows for surface electrodes to record genioglossus muscle activity in a non-invasive way. These recordings determined muscle strength during swallowing with different head positions. As direct therapy was implemented through different food consistencies, the strength of the genioglossus muscle was recorded during the time of swallowing in either the chin tuck or chin up position. Chin tuck posture improved swallowing, while the chin up position showed no significant improvement. Our final outcome concerned improvement in participant perception of swallowing as it affects day-to-day living. Using the SWAL quality of life, participant perception was measured during the pre-treatment baseline phase, following treatment 1, during the second baseline phase, following treatment 2, and at the conclusion of the study. These measures provided a view of each participant's perception of how their dysphagia impacts their life. Using the 5-point Likert scale ranging from 1 most severe to 5 least severe on the SWAL quality of life, participants rate each of 12 areas about swallowing problems, including how it has impacted their social life, desire to eat, and overall fatigue. These differences allowed for a comparison of participant perceived quality of life in direct and indirect therapy. That concludes our presentation for Step 5. Thank you.